Hello, in this video we are going to discuss the problem word break part 2. Okay, so in this problem what we are given is that we are given with a string, okay, and a dictionary of words of length n. Okay, we can add spaces to this s to construct a sentence in which each word is a valid dictionary word. Okay, so also each dictionary word can be used more than once also, that is also possible. So we have to return all such sentences. Okay, so there's also a program, there's also a problem where we have to count such sentences, but here we have to also backtrack. Basically we apply dynamic programming algorithm here, and also we have to basically output return all such possible sentences. For example, in this case where s is cat and dog, so out of this string, two possible sentences are there. First is cats and dog. Second is cat, sand, dog. Okay, so you can see out of these sentences, all the words of these sentences are present in the dictionary. Okay, so these are two possible sentences. In this case, you can see which is cats and dog. There are no such possible sentences because their one D is missing. So we have to just output the empty vector. So this is how we have to do. So basically we will be given with a string and a dictionary array, and we have to find out how many possible sentences are there. So let's understand this problem with the help of whiteboard, and let's take an example and see how can we perform this particular algorithm. Okay, so if we take the case, the first test case which is given to us. Okay, so the first test case which is given to us is this one. Okay, we will discuss this one test case in our whiteboard. Okay, so let's discuss this. Okay, that how we are going to do this. Fine. So you can see here that the value of string which is given to us is cats and dog. Okay, and the length of this dictionary array is 5, of this vector is 5. That is what is given to us. Okay, now for this, to perform this problem, there is a solution which is, you can say, a brute force solution, in which you have to basically check for each and every subsequence of this s. You have to check for each and every possible sentence that is basically can be created, can be constructed from this string, and then you have to check that whether all the words of that sentence are present in the dictionary or not. But that brute force approach will take complex time complexity, very high time complexity. So we have to do it in a less or minimum time complexity. So for that we will use dynamic programming, because using dynamic programming and using memorization, what we can do, we can reduce our time complexity. Okay, so that is why we will use dynamic programming algorithm here. So now let's see that how we will do that. Okay, so first of all, what we will do, we will take a string which is cats and dog. Okay, so we'll take that string which is cats and dog, okay, which is given to us. Fine. Now what we can do is that we have to check for each and every possible subsequence. So the first is subsequence, which will, what we will do is that we will iterate from the back. We will iterate from the back, and then we will take a substring from the back. Fine. So what we can do is we can first take this index. That is this G present in this dictionary or not? It is not present. So we will again iterate to the next thing. Now here O, is this OG present or not? No, this OG is also not present in this particular dictionary. Okay, now what we will do, we will check for the next one, which is DOG, means dog. Now you can see that yeah, this dog is present in that particular dictionary. That dog word is present. So now what we can do, now we have to know that yeah, we can separate this dog from the rest of the string. Okay, that is what we know now. So now we will separate the dog from rest of the string. So now it will call recursively operation. It will recursively call that operation. Okay, how it will recursively call? It will again call that same operation, but now for the substring. And now it knows that now we have that dog as our substring, which is present in the dictionary also. Fine, that is what we can do. So what we can do, we can just divide it into cats and this dog is now separate string. This is what we have done. Okay, this is what we have done. So similarly, this is now a separate function because we will just recursively call for this substring now, for this substring. But before doing that, now we will also iterate once more to check is there any more substring possible or not. But you can see if I will just iterate more and more and more, there will be no such substring possible that it is present here. Maybe if there is one more word and dog, so you will also get maybe this is present. Okay, let's take example. So what will happen is that you can just take that at this particular index. Okay, at this particular index, this substring is also possible. So you can also make like this, cats, and this as separate. But because that is not present, we will not take it because that is not present in the dictionary. That is what we have just assumed. Okay, and we will just also remove it from here. Okay, so this is what we will do. This is what we will do. Now, how we can solve it? That okay. So now we will call. So now for this particular string, we have checked for each and every index, and no more such substring is possible. So now for this recursive call, we will check for this particular substring. So for this particular substring 2, we will check for each and every index from the end. So from here, is D present? No, D is not present. From here, is ND present? No, ND is not present. Now from at this particular index, A and D and is present in the dictionary. And is present in the dictionary. Okay, so now we will take this and now it will recursively call for cats and dog. Okay, now then also we will not stop. Then also we will check for the next also. We'll check for the next also. So for next, when we will add sand s, then you can see sand is also present. So means we can divide that particular substring from sand. So there will be two recursive calls. First for and second for cat, sand, dog. Fine. This is the thing. And now we'll just again move again. But then we will not get any of the substring present. Now we'll check for this particular substrings which are here because that is what we have got from the last two operations. Now for this substring, you can see no such present is there. It is just present for this whole. So from here we will just break and then we will just output that there are two such sentences which are possible. So this is what we have to do. This is what we have to perform to complete our algorithm. So now let's move towards the code part and understand how we can solve this particular approach which we have discussed. How can we implement it? So this is how we will perform this algorithm. And similarly, there is one more case that because what we were doing was that we were iterating from backside of this string. We can also iterate from start side, and then we can check for this particular substring. From here, we can check for this substring it is present or not. So that is also a possible case. Okay, that is also a possible case. We can iterate from backside also, or we can iterate from front side also. The thing will give the same solution. It will give the same solution. So what we will do, we will now just implement our solution, that how we can implement it, how we can code it. Okay, so this is our code editor. Okay, now just first okay, now what we will do, we will first take a map. Okay, and that map will be a map of string comma vector of string. Means that map will basically store the sentences which are possible. The sentences which are possible for a particular string. Fine. So we will take that map. Okay. So that will be, we can take another map also, which will be of string comma vector string. And okay. And let's name that map as m. Okay. That is what we can do. Fine. Fine. So this is the thing which we can do here. Fine. Now the next step. The next step is that we have to basically check for each and every word that is present in the dictionary or not. So for that we have to also take one more unordered map. Okay, so let's take the unordered map, name is MP. So let's take an unordered map. Okay, let's take this unordered map, and in this unordered map we will just store that a particular number is present or not. Okay, fine. Or we can also take a set. We can also take a set this time to just check that in a particular that in a word is present in that dictionary or not. So we can just take a set of a string, okay, which let's name M, and for all the elements of this dictionary vector, okay, of this dictionary vector whose size is n, which is given to us, okay, we will just insert it into our set. Okay, this is what we will do. Okay, I hope that this is clear. Fine. Now let's see that what we can do now. What we can do now. Now what we'll do, we will just, because we have to make recursive calls, we have to make recursive calls now. So for that, let's create another function. Let's say recursive function. In that function, what we will pass is, what we will pass it, that we will just pass, let's create a function. Okay, and that function we will just pass the string given to us, this s, and this dictionary is not required. We just this set m is required. Okay, this set m is required because we have basically extracted all the words of that vector and placed it in a set, so that it is easy to find that our number is present or not. We can also use map there, but we have used set. You can use anything. Fine. So now we will create a function. Okay, and in that function we will have two things, and that function should basically return the vector string, the answer for a particular string. Okay, and let's call it, you can say, because it is a recursive function, so we can find that sentences. Let's name that sentences. Send. It will return a sentences possible for a given word. Okay, and that will basically take first the string s, and then this particular, let's say m only, this unordered set. These are the two things that particular function will take, and it will take the reference of it. So let's make it reference so that any change can be there. Okay, fine. Now what's the thing? Fine. Okay, so now we have to also pass it here. Okay, and because we have taken a map of name m, so we can take it mp now. Here we'll take it as mp. Okay, now what we will do, we will also call it here, and basically we have to return the value which has been declared by there. Okay, so we can just return that value, that return the value of this send s comma m. Okay, now we have to basically code this particular function. That is our thing. Okay, that is our thing. Now the thing is that because we have taken this m, this is basically a dp unordered map, means if for that particular string, which is s, if we have already got our answer, and what is our answer? If we have already got our answer, then what we will do, we will just return that answer. That yeah, for that particular string, we have already calculated our answer. We have already computed our answer. So we will just return it. Okay. Now what we will do is, now we will here create a, let's say, a vector result, in which we will store the result. Okay, that is what we will do. Fine. Great. Now what we will do is that we will just check that that particular string is present in that map or not. For example, that whole string is present in that map, in that dictionary. Then we will just push that whole string into the result. If that whole string is present in the dictionary, so we'll just check that if in that map, means in that dictionary, this whole string s is present. Okay, in that case what we will do is we will just push it into the dictionary. Okay, that is what we will do. And else, if it is not present, or let's say it is present also, then also we will check for each and every subsequence, each and every substring for that particular string. For example, let's say in this case what we are doing, we are just iterating and checking for each and every substring after that index. That is what we were doing now. So that is what we will do here also. Okay, so for that we will just take for loop. Okay, and that for loop will start from 0 and will run up to s dot size I plus plus. Okay, now what we will do is that we will just extract that substring which is starting from this index I. Okay, let's take that, let's name that string remainder. Okay, and which is basically a substring which is starting from that index I. Okay, which is starting from that particular index I. Now we'll check that because that substring should also be present in that dictionary. So we'll just check that if mp.find, we'll just make that a statement, just copy this statement, that if that string rem is present in this map, In that case, we will just, what we will do, in that case, what we were doing was, just check that what we were doing in that case. Okay, let me just tell you, let me just check that how we can do that particular thing. Okay, so this is something like that. We will have, in this case, what we will do, that if we have got that particular, string that, yeah, this and was present. So what we were doing, we are first pushing this and, into a sentence, and then we are recursively calling for this particular substring. Okay, so this is what we are doing. Okay, so now the same statement we will do here also. So first what we will do is that we will have this particular thing. Okay, now what we will do, the first statement will be that we will recursively call for the rest of the substring, means substring from 0 to I, the rest of the substring. So we will recursively call for it, and we will store its answer in a vector v. Then what we will do, we have to just push that particular word into our sentence, and our sentence is stored in basically in this vector v. Okay, so what we will do for that, we will also write a function. Okay, and let's name that function is basically combine, that will basically combine our given word to the vector array, to all the vectors which are, to all the sentences which are possible. Okay, so this is what it will do. So it will just make like this, that will combine v w, and then for each and every value of this, you will just combine it, means vi will be equal to, we also add a space and plus w. That is what we will. Okay, that is what we will. And here we will take a reference of this vector v. Okay, so that it should be changed, should be reflectable. Okay, now great. So now over here we will just combine that. Particular vector v with the word which is basically w. Okay, and what is w in this case? Which is remainder. That remainder, because that is present in the dictionary. No? So we'll just push it. Okay, and then we'll just push this whole vector v into the result. Result means the whole is dictionary which you have to output, the whole answer which you have to output. So we just insert that result into the vector which is here. Fine. This is what we are doing. And when we will just calculate it, then what we will do, we will just make the value of that map is equal to result, and then we can just output result. We can just output result and then make its value. Okay, this is what we are doing. Okay, so now we'll just run it. Now what we will do, we will just run it. Okay, we will just compile it and we will just run it. Okay, let's see what is the output. Okay, so here we have just got that it is MP. Okay, so in this cal we have this MP, it is right. So what's the problem here? It is saying that that is not declared. Okay, fine. So we are pushing this MP vector here and then we are using it here. It is right. Now let's just compile it. Okay, here it should be basically this sentence. Okay, that is the fine. So here we have got it, and here we have this dictionary array. Okay, this dictionary vector here. Okay, and we are just inserting it into the MP. Here it should be MP. Okay, MP. So it was the set, we have made it MP. Na? Great. Fine. So you can see that here is the right answer. Now let's submit it. Okay, so you can see that we have got right output. Now if we talk about the space complexity and time complexity for our particular solution, okay, space and time complexity for our particular solution. So it's, if we talk about for space complexity, okay, so for space complexity we are taking a map, and that map we are storing, map is of string comma vector string. So the maximum, okay, this is what the map is, string comma vector string. So the maximum length of the string can be n, means n is basically a string of the length of our string event, and the maximum length of this vector string is also n. So overall space complexity will be O of n squared. And if we talk about the time complexity, so we are checking for each and every subsequence, means we are iterating through the string given to us. Okay, so for iterating through the string, it is taking O of n time. Okay, And then what we are doing, for each iteration, what we are doing is checking that is that word present in the dictionary or not. So if there are n words present in the dictionary, so basically we have to make n times that to it. Okay, that is what we have to make n times. Okay, fine. And also checking for each and every subsequence will require O of n square time. This is required for checking for each and every subsequence. And because there are n words in the dictionary, so over time complexity will be O of n square into n. Okay, fine. So that is what the time complexity and space complexity is. Okay, so I hope that you have got this video. If you have any problem, if you have any doubt, you can just comment it down, or if you have liked this video, please like the video, hit the like button, comment, share this video with your friends, and subscribe to this channel.